Every river begins with a single droplet. Even the longest river on Earth, somewhere high in the mountains of East Africa, a droplet forms. It gathers silently. From mist, from rain, from melting ice hidden among stone and grass. It does not know where it is going. It has no memory, no intention. Yet this droplet will travel more than 6,600 kilometers. It will move through cloud forest and open savanna. It will pass through vast lakes, narrow channels, and ancient valleys. It will cross deserts where nothing grows, and cities where millions depend on its arrival. This droplet will touch ice, and later sand. It will be warmed by equatorial sun, then cooled by night winds moving off the desert. Most people who rely on this water will never see where it began. They will never stand at its source. They will never know the mountain, the forest, or the rain that gave it form. But every glass of water, every irrigated field, every riverbank settlement, is connected to this beginning. This droplet will become part of the Nile. And to understand the Nile, we must follow the journey backward, to a place far beyond memory, far beyond history, where geography, climate, and time quietly come together. 1. The Nile, a lifeline through desert. On the banks of the Nile stands Cairo, a city of more than 25 million people, surrounded by desert. From the air, the contrast is unmistakable. A thin green ribbon cuts through a vast expanse of sand and stone. Life clings to the river's edge, while beyond it, the land turns dry and silent. Without the Nile, Cairo would not exist. For thousands of years, this river has delivered water, soil, and stability to one of the most arid regions on Earth. Seasonal floods once spread nutrient-rich sediment across the floodplain, renewing fields year after year. Trade moved along its current, binding distant communities together. Ideas, beliefs, and technologies traveled with the water. When the pyramids were built, the source of the Nile lay far beyond imagination. No expedition had traced it. No map reached that far south. To the ancient Egyptians, the Nile did not need an origin. It was eternal, a divine gift that arrived each year, on time, without explanation. They worshipped its cycles, measured their calendar by its rise and fall, and aligned their civilization along its flow. Yet the river that sustained Egypt did not begin here. Its journey started far away, in landscapes utterly different from desert stone. To understand how a river can sustain a civilization, we must leave the monuments behind and travel south, toward rain, mountains, and forests.
The African continent is slowly
a source
being ripped
far
apart
beyond
by tectonic
imagination.
forces, forming the Great Rift
The Nile
Valley and
does not
revealing the Earth's
begin in
mantle
Egypt.
below.
It does not even begin in a single place. Its origins lie almost 7,000 kilometers to the south, in East Africa, within a vast and complex system of water. Here, rainfall does not fall once and disappear. It is captured, stored, redirected, and released across mountains, forests, rivers, and lakes. The Nile is not born from one spring, but from a network. At the heart of this network lies the Great Rift Valley, a massive fracture in the Earth's crust, slowly pulling apart for millions of years. Tectonic forces have raised mountains, created deep basins, and shaped the pathways through which water flows. Rain that falls here does not rush quickly to the sea. It lingers. It collects. It waits. Some of it becomes mist clinging to high slopes. Some freezes into ice. Some sinks into wetlands and peat-filled swamps. Over time, gravity gathers these scattered waters and draws them northward. The Nile is not the result of a single dramatic
driven
event.
by the intense heat below,
It is the outcome
responsible
of
for both
patience,
earthquakes and the
of
creation of mountain
terrain
ranges.
shaped slowly, and water responding quietly. To follow the river further, we must climb upward, toward the mountains that feed it, where cold and altitude play an unexpected role in the life of a tropical river. 3. The Mountains of the Moon, Rwenzori. Rising directly from the equator are the Ruwenzori Mountains. Despite their location, their highest peaks are capped with snow and ice. Clouds gather constantly along their slopes, wrapping the mountains in mist. Ancient Greek geographers called them the Mountains of the Moon. They believed these peaks fed the Nile long before anyone had seen them. Today, we know why. Moist air from the Congo Basin moves eastward until it meets the Ruwenzori Range. Forced upward, the air cools, condensing into heavy rain and snowfall. Glaciers form near the summits. Below them, alpine bogs and saturated soils store meltwater like sponges. The Nile is often described as a river of heat, flowing through desert, but its reliability depends on cold. Snow and ice release water slowly. Even during dry seasons, they smooth out extremes, turning violent rainfall into steady flow. As climate warms, these glaciers retreat. Their disappearance is gradual, but the change is permanent. What remains is a reminder that even rivers in the tropics can depend on ice. From these cold heights, water begins its descent, leaving rock and snow behind, for forest and life below. 4. From ice to rainforest. From glaciers and alpine swamps, water descends. It moves through cloud forests, where trees drip constantly, their leaves coated in moisture, even when rain does not fall. Here, nights are cold. Days bring intense sunlight. Life survives by adapting quickly. Plants grow low and dense. Animals move carefully, timing their activity to warmth and shelter. As altitude decreases, the forest thickens. Rainforests emerge, fed by constant water and rich volcanic soils. Even before it becomes a river, the Nile already sustains life. Every drop supports insects, roots, fungi, and unseen microorganisms that form the base of complex ecosystems. Water here does not rush. It spreads. It seeps. It feeds. Only gradually does it gather into streams, then tributaries, then recognizable rivers. By the time the Nile takes shape, it has already passed through some of the most biologically rich environments on Earth. And still, its journey has barely begun. 5. The Great Lakes. As the Nile's waters move northward, they enter a series of vast lakes. Lake Edward and Lake Albert act as natural regulators. They collect inflow from multiple rivers, store water during wet
From the fiery
periods,
destruction of the eruption,
and release
new
it
life
slowly
emerges,
during dry
demonstrating
ones.
the incredible resilience of
Floods
nature.
are softened. Droughts are reduced. Without these lakes, the Nile would be unstable, prone to extremes that would make life downstream unpredictable. The lakes transform chaos into continuity. Sediment settles. Flow becomes measured. Seasonal rhythms emerge. For thousands of years, this stability allowed human communities to rely on the river's behavior. These lakes are not merely reservoirs. They are buffers between climate and civilization. As water leaves Lake Albert, it continues northward, steady and persistent, moving toward its largest holding basin. 6. Nyungwe Forest, the farthest drop. In Rwanda Nyungwe Forest, rain falls almost every day. This ancient montane rainforest captures moisture from passing clouds, feeding countless small streams. Here lies what many consider the farthest source of the Nile, a quiet channel, 2.700 meters above sea level. There is nothing dramatic about it. No marker. No monument. Just water moving downhill. Each droplet that begins here will eventually pass through lakes, cross borders, and flow into the Mediterranean Sea. The journey takes months, sometimes years. Most of these droplets will never be noticed. Yet together, they sustain a river that shaped history. From this distant forest, the Nile gathers strength, not through force, but through accumulation. 7. Lake Victoria. Lake Victoria is Africa's largest lake, and the Nile's greatest reservoir. Spanning 3 countries, it holds water gathered from countless rivers and rainfall across a wide region. For thousands of years, this lake supported one of the most diverse freshwater ecosystems on Earth. Hundreds of cichlid fish species evolved here, each adapted to a specific niche. Different jaws, different diets, different behaviors. Then humans intervened. In the mid-20th century, the Nile perch was introduced to increase fish production. The result was catastrophic. Native fish populations collapsed. Food webs unraveled. Water quality declined. For decades, the lake reflected the consequences of ecological imbalance. Today, the system is changing again. Fishing pressure has reduced perch numbers. Some native species are slowly returning. The recovery is incomplete, but it is visible. Lake Victoria reminds us that large systems are resilient, but not invulnerable. From its northern edge, water begins to accelerate. Here, the Nile finally takes on the character of a river. With a single direction, the Nile is born. In the northwest of Lake Victoria, water erupts into foaming rapids. The lake releases its hold. Here, the Nile becomes a true river. Its path is set northward. From this point on, gravity guides its course across plains, through gorges, and into the heart of the desert. What began as mist and ice now moves with certainty. The Nile will no longer spread. It will travel. Conclusion: the Nile is not a miracle. It is the result of geology, climate, life, and time. One droplet, joined by another, and another, until continuity becomes flow. Civilizations rose, not because the river was magical, but because it was reliable. Even today, millions depend on waters that begin far away, unseen, and unremembered. Every river tells a story. The Nile tells a long one. And it begins quietly, with a single drop.